Hello and welcome to Func Prog Sweden. My name is Magnus and I'm the organizer of Func Prog Sweden. First, warm welcome to all our recurring guests. Thank you very much for following us at Func Prog Sweden, and thank you very much for your participation and your shout-outs in the chat and all the questions you ask. Thank you very much. It means a lot to me and all the other organizers, but also a lot to the people doing presentations here at Func Prog Sweden. And to all our first-time visitors to Func Prog Sweden, this is the MeetUp and YouTube channel where we explore functional programming and functional programming languages, concepts, and more. You should check out all our old YouTube vids where you can find a lot of good content. Now, let's head over to today's agenda. First, me, short introduction. Then, Erlang, Nearly in Space by Dieter Schön. Dieter has built a test framework that tests satellites that are sent out into space. And once in space, yeah, you can imagine it's hard to do updates, meaning it should work. Then replace your ORM, ORM, with Relational Algebra by Christoffer. Are you tired of doing database stuff? This might be a solution for you. Check it out. And in the end, as always, if you have more questions, anything you want to ask the presenters, head over to the Discord server where you can ask them. First, I would like to present or thank our video sponsor, Beat. Thank you very much. If you want to know more about Beat, head over to their webpage, otherbeat.com, or check them out in social media. Then the schedule for the coming spring. 18th of March, we will host an in real life event at Kivra. So if you are in Stockholm and at 18th of March, make sure to check out the meetup and come and see us in person. There will also be, we will announce the presenter within a week, and I think it will be very interesting. 16th of April, we're back again with another meetup, and then we haven't decided the dates yet for May and June. Oh, it says May and May. Anyway, May, and of course, we will come back in June also. To support Func Prog Sweden, make sure to follow us and subscribe us at MeetUp and at YouTube. And if you want to ask more elaborate questions or things to our presenters, please make sure to join the Discord server. You'll find an invite below the channel or in the meetup group. And if you have any questions during the presentations, use the YouTube chat or, as I mentioned before, the Discord server. So with that, let's start. Welcome, Dieter, to Func Prog Sweden. Hello and welcome, Dieter. We are looking forward to your presentation, Erlang Nearly in Space.
Thank you.
You're welcome. The stage is yours.
Okay. Hello. My name is Dieter, and as Magnus told, I'm applying Erlang to test satellites while they're on the ground and being manufactured. So a bit of an introduction. I work for Therma, which is a Danish company. And my department is located in Vienna. We are working in the space business, have been working for the last 40 years. I have been here for the last 25 of them. And yeah, our test equipment, which we produce, is usually delivered to spacecraft manufacturing companies, as the Airbus, Thales, in Germany, OHB, and is used there. Now and then I will need to introduce abbreviations. SCOE is an abbreviation for such a test system. It's a special checkout equipment. Some of these systems are transported to the launch site where the rocket is launched and provide the spacecraft with power until the last moment when the rocket launches. Personally, I learned what I started with was Fortran. In school, we had an old IBM, and later I also used PDP-11. This should give you an impression how old I am. And more privately even, I'm married. I have two boys, which are nearly no longer boys. They're 18 and 16. And I'm working and living in Vienna. So this would be a typical setup at a spacecraft manufacturer. This is probably an engineering model of a spacecraft. An engineering model is designed to get familiar with the spacecraft behavior, and it's never intended to go into space. Therefore, it doesn't need to look like at the real spacecraft. And this rack, I hope you can see my mouse pointer. This rack in the background would be one such test system delivered by us. This actual picture was taken at ESTEC in the Netherlands for the Galileo systems. So, and at the spacecraft manufacturer, the test topology looks like this. The green block represents the spacecraft, and there it has several components depending on the spacecraft. Communication for radio frequency, power, usually it has a solar array and a battery, and several instruments depending on the purpose of the spacecraft. All is controlled via a central checkout system, and then there are dedicated test systems which each test one functionality of the spacecraft. And these systems are produced by my department. And as I said, there are different stages of testing. You start with an engineering model, which is not designed to go into space. Then you have a pre-flight model. Depending on the success of the test campaign, this may go into space. And then you have one or more flight models. For the first Galileo stage, there were 4 flight models. And for most of our projects, it's only one satellite. In 95% of our projects, the customer is ESA, and they built nearly exclusively scientific satellites where you only need one of a kind. Internally, we have 4 subdivisions. We built radio frequency scores, which test the communication part of the satellite, power, which test the set array, the solar arrays, and you also have to test the eclipse when the spacecraft goes through the Earth, to the shadow of the Earth. It's necessary that it's still powered by the battery. And yeah, this has to be tested. And our test system can also act as a load. If you want to test the battery, then we simulate the spacecraft and we consume the power of the battery or the solar array. Next subdepartment is instrument or payload scores. There we have data interfaces to the instrument, and we test all the functionality of them. And last subdepartment is not space related. Some colleagues have a new application for our power devices and found that they could, with some adaptations, can be used to be used as a battery cell tester for the automotive industry. So this is an RF rack. It's a 19-inch rack, usually around 2 meters high, with spectrum analyzers, network analyzers, signal generators. So the signal generator sends the signal to the spacecraft, and the analyzers then measure the quality of the signal. And because you can have several tests, we have switch control matrix, which can route the signals on different ways. So you can test all the relevant subsystems of the satellite. And in the bottom layer, there's the power distribution unit. Oops, wrong direction. So most of our applications are have been written in C++ or Tcl, have a fixed architecture. So it's bespoke software. For each mission, no mission is like the other. So you always have to make bespoke software. And what was that? Anyway, so we have this approach to build an application for one mission. And I thought of, it's of course a reinvention of the wheel, to build a modular system which can be used to quickly have application which uses this standard building blocks and quickly compose an application of it. What fascinated me on Erlang was the actor model and the binary pattern matching. It's super fast to write parser for a binary network protocol. And I also used the late binding mechanism. I call it this way, it's not in the official Erlang documentation, because you can send a signal to any process, and you could, by using a different process module as the receiver, you can have, and you can exchange this during runtime. So I will come to this in the next slides more deeply. So my idea was we have the same, a common set of requirements in our missions. We have a set of network protocols. We have sockets or file interfaces. And there are, I think, a dozen more building blocks which I defined. And I gave them standardized interfaces, so they are able to receive the same message. And I can very easily, for example, replace a socket with a file, or I can replace the CNC interface with the Eden interface. Or I can, if it's only a receiver, I can use the pickup module to save it to pickup files which can be read later with Wireshark. And the second thing which I use in my framework is programmatic configuration. These little, I'm not sure if it's readable, but these little yellow boxes represent instances of these building blocks. And I have functions, an API, which is able to define such a tree, and which then, if applied at runtime, create this tree of processes where these are supervisors. And so you can quickly instantiate an application. And if you have the need for a different application, then it's just a matter of using a different configuration file or just removing this this device tree and instantiating another, then you have a completely different application. So next, I will introduce some of the missions where I used my framework. The first was for an instrument score. It was the microwave sounder for MeetUp satellite. Here I had a problem. If you have seen the movie Apollo 13, they had a problem with air filters. They had round filters and square filters, and they didn't match. And in my case, I had a problem. These two were applications from the customer, which spoke different protocols. And the screen block was software which could talk either one protocol or the other, but not both at the same time. And it was necessary to connect both. And oops, my solution was the red box, which I was able to do with instantiating one block for the CNC protocol, the other with Eden. And I had another module which was able to transpose this protocol units. So this was then the solution for this problem. My second project was for the Space Rider, which will be this part here, a reusable container for supplying the ISS or maybe some future similar space stations. The customer had two power scores, which were meant to run in the redundant scenario. They both supplied they both were connected with the spacecraft. And in case of a failure of one of them, there should be instant hot standby switch over to the other system. And one requirement from the customer was that the central checkout system should only see one score, one virtual score. And my solution here, called Hot Red, was to distribute the commands in the direction from left to right to both of the scores, and the replies only use the one from the active. So one problem here was because I just read what was coming in on the socket and sent it immediately out. Those packets were from time to time subject to the TCP segmentation. And if a failover was happening right in the middle of a segmented packet, then the CCS received a partial packet and closed the connection. So I had to introduce a bit of a higher protocol-aware layer to reassemble the packets, and I introduced an update to the customer and have not heard anything ever since, so I assume it's running. The next project was for application was for RF score. The project is Crystal. It will be a mission to measure the ice thickness, if I can read it correctly. And we produced two versions for different radio bands, for the KU band and for the KA band. The hardware was Beaglebone Black, a small embedded device about the size of a credit card. And because it has an eMMC memory, initially we thought of using a Raspberry Pi, but there are only SD cards are available, and the customer rejected this idea, and because of eMMC is more reliable. We had some hardware-related problems, but there were no big blockers. It's just the BeagleBone Black has some I/O pins, and most of them have 3 or 4 functions. And if you have connected the wrong pins during the system during boot, then it behaves a bit funny, but we learned our lessons. The system also has a network connection similar to Skippy, which is used in measurement devices. So this is a picture of the RF parts. The blue cables are microwave cables. In the upper part of the spectrum at 40 gigahertz, I think the wavelength is about 7.5 millimeters. So it's very important that the length of these cables is matching. Otherwise, you get some phase differences and a lot of problems. I'm not an RF engineer, I'm just laying what the colleagues had to find. And the other side shows my BeagleBone Black. I have connections to this RF switches and also some temperature sensors here. And there should also, here's the network connection. These are my interfaces. And I also wrote GUI, just a small web interface, which can be used to control the device from a PC or laptop switch position. And you get the real-time reading of the sensors. This is done in Elixir with live views, so it was quite easy to get the real-time info from the device to the display. So now we are leaving the space domain. This is for a new product, the battery cell tester. It's here in the test setup. This is not the final version. And in these 2 racks are several power supplies and measurement devices. And somewhere here should be a 19-inch controller, which contains my test framework, which I wrote. It uses test scripts written in Erlang, and where you can define test sequences to test all necessary interfaces of the device. I'm sure it's not completely video. This would be one example of a test sequence. In the beginning, there's initialization of the test devices. I have this is a duck which is here to collect measurement data, a power supply. All these devices are defined in a Postgres database with their IP addresses, their limits, their serial numbers for test reports. Then the main part of the test sequence would be to apply power, to make measurements, to loop and measure a current in a loop. And at the end, to make it an automated test system, there are functions which check if the measurement values are in the defined ranges, and so to conclude if the test was successful or not. And the system then produces a test report in various formats, in JSON, CVS, CSV and PDF. Depending on what is tested, I dynamically can load the needed instruments. And so this would be one test with 2 devices and another test which uses 5 devices. And yeah, that's about it. Then, because some colleagues were very paranoid, and the device under test is quite expensive, so it's necessary to protect it and do not let it destroy by wrong, for example, voltages of the power supply. So I wrote an AP. Well, I used the Erlang functions to read a script from a file and to parse it into tokens. Then I can, if needed, I can add variables into the state of this interpreter. And if I then execute, this is done in a loop, I can intercept each function call and, for example, check if the voltage is in the allowed range, or if some errors have been introduced. So this is just a peek into my next project. It's called MechSim. It will be the simulation of stepper motors on a spacecraft. There can be up to 60 stepper motors in a spacecraft for the solar arrays, for the positioning of thrusters or antennas, and they also have to be tested. And the idea here is to simulate the stepper motor. The spacecraft will send the stepping signals to our test system. We will read the signals, then calculate the new position of the stepper motor and respond with a virtual potentiometer readout, which gives in analog the virtual position of the motor. So this is in the design phase, and there's not much more than this sheet here. So conclusions from my test system. Erlang is very suitable for my way of thinking or of working. In other programming languages like C, C++, or Python or whatever, when a project reached a certain state or size, I tend to lose the focus and the overview. But with Erlang and the modules, it is for me quite easy to keep the overview and to know what functionality is where and where I have to look if I need to make some adaptations. The other items are, well, the usual, the properties of Erlang. There are no global variables to spoil the namespace. I use exclusively gen servers, so the internal state is encapsulated and not visible on the outside. It has nothing to do with OO, which suits my mind very well. Rebar Auto. This is Rebar is a building tool for Erlang, and Auto is a module which rebuilds every time a file is changed. So if you write your code so that or in most cases, when you do a file save and do not change the internal structure of process, then they will survive and have automatically the new state applied. It's like hot reloading just in the development phase. And also the single assignment of variables is very nice feature for me. There's only one assignment to a variable, and then I know what's in there. I think, yeah, that was my last slide. That concludes my talk, and thank you very much for listening. Back to you, Magnus.
Thank you very much, Dieter.
Thank you.
Yes, let's see. I'll take a question immediately that came up in the chat. The question is, I didn't get the custom DSL to launch process. Is it similar to the .app file that holds the metadata for the application behavior?
But I did not understand at the beginning. I did not
like
get
when you launch the DSL,
yes.
how do you use, how do you load the metadata?
When you mean here when I said that I can inject variables?
Not really. I think it was earlier. Anyway, yeah, inject variables, but like how do you use the metadata? Where do you store the data for the test as such? Do you use them as metadata, or I would say like the test data, you know, the data you need to like instantiate the actual test.
Yeah. The data which are or in this test bench environment or test parameters come from a Postgres database. And yeah, afterwards the results are also written back to a Postgres database. And where I do not use much of the functionality of Postgres. I use it more like a key value storage. With, of course, all linked together to represent in sum the result of one test sequence.
How do you present the data? Do you use the common test output, or do you use some other like dashboard or something to present the data for, like, I don't know, stakeholders, developers, whomever is interested in?
I use common test to test my software internally, but for this test bench, the primary visualization is PDF reports. With tables, and I can include graphics, mostly XY plots. And for some colleagues who will use my test results, then they can export the test data as JSON or CSV files.
Okay. Yeah, from the Postgres database, you mean?
Can be used exported from Postgres, or I also directly, well, no, I have to correct myself. It always comes from a Postgres database. This is the source, the single source of truth.
Yeah, yeah. You need one single source. It's usually easier than to have multiple sources. No more questions in the chat, but I'll ask you, like, when did you come in contact with Erlang, and how did you? How can you pick it up?
That was about 10 years ago. A colleague was coming back from a trip to, I think it was Stockholm. There was a meeting about, I think, functional software in more general. My colleague was coming from the Haskell side. And when he came back, he gave a short talk about his impressions. And he mentioned Erlang. And yeah, then when I became, I got big ears and investigated and researched, and yeah, was caught instantly.
Okay, interesting. Yeah, this is why we should continue to run meetups and have conferences to spread functional programming.
Mhm.
Yes, let me see. No more questions in the chat. Again, thank you very much, Dieter.
You're welcome.
Thanks. Now, we have just listened to Dieter and his very interesting presentation, Erlang Nearly in Space. Now over to our next speaker that is with me here in the studio, Christoffer Ekeroth. Welcome to Func Prog Sweden.
Hello, yes, it's nice to be back again.
Yes.
Back in the studio.
Yes.
Yeah, this starts to feel like a talk show, I think.
Yeah, you should say some bad functional programming joke now.
I don't know. I heard something. I've got one for you.
Okay.
I have a Haskell joke, but it's very lazy.
We have to add that sound later. Yes. Well, the stage is yours, Christoffer. Welcome.
Yes. So today I'm going to talk about something I decided to call Scrap Your ORM. And basically it's about how you can replace your ORM, your object relational mapper, with a DSL based on relational algebra. Okay, that's a mouthful. But first, some introduction for those who are not familiar or haven't seen one of my presentations before. I'm Christoffer Ekeroth, and I'm at Cracky on Blue Sky. I also run a company called Functional Software. We work with consulting and recruitment in the functional programming space. And this talk is tangentially related to functional programming, I would say. It works very well with the functional programming paradigm. But yeah, you'll have to excuse me, but I'm going to run some demo code, and it's written in Python. I know this might offend some people, but yeah, I need a quick prototype. But anyway, so the agenda for today is like, first I'm going to explain the motivation behind this. Then I'm going to move on to introducing relational algebra. Then I'll show how to create a query DSL based on relational algebra. There will be a demo and, well, some concluding remarks. And like Magnus said earlier, if you have any questions, just feel free to like shout out in the chat. It's the YouTube chat, right? And also, while you're looking at the presentation, I'm going to ask you also to try to think of some things you might be wondering about the IMDb top 250 movie list. That will become relevant later. I'm just going to say as well that, I mean, this is not really revolutionary stuff, I think. I mean, I can bet good money there's already a Clojure lib that does this, because they're really into, like, you know, data. And yeah, what was it? Yeah, it's like I said, it's nothing revolutionary, but I hope this could be useful to someone. Anyway, as most of you know already, like most business systems store data in SQL databases. And there are usually two common ways to access this data. One is just by like writing raw SQL queries by hand. And hopefully you also use parameterized queries so you don't get like SQL injection attacks. But basically it's just, well, writing out the SQL you would use and then sending that off to the database. But there's a second paradigm that's also very common, which is to use an object relational mapper, which is basically like a, what would you call it? Like an object-oriented interface to the database. And both of these have their pros and cons. I'm just going to walk through them real quick now so you can get a feel for like what does the like existing solutions look like. So obviously, one big pro of using a ORM is that it's familiar. You use classes and methods to write your queries. So it kind of looks a lot more like the rest of your code base. But another big advantage is that it's usually composable as well. like if you have a query that's created in your ORM, you can usually pass that around and refine it. You can filter it some more, etc. However, there are some cons as well. And the first drawback is that it's usually kind of limited. It doesn't really, most of them don't expose like the full power of SQL. You get a limited subset. And also, ORMs tend to have this like tight coupling problem. I mean, you can go back and watch, Rich Hickey's famous Simple Made Easy presentation. And like, he made a pretty good case for like, the fact that ORMs are, well, they complicate stuff. Like they couple a lot of things together. Like you have the way you do queries. It usually handles the DB connection as well. It also does serialization, etc. So there's a lot of things you opt into when you choose an ORM. And okay, so what about writing raw SQL? Well, first of all, the obvious advantage is that you get access to the full power of SQL. You also get, like if you have vendor-specific extensions, for example in Postgres or MySQL, you can access those as well. Usually those in a lot of ORMs, since those are not available for all databases and the ORM wants to be portable, those can be like, well, not accessible. Second pro is that basically we're just doing like advanced string manipulation. So it doesn't require anything more than a connection to the database. However, one big con is that usually you just build strings, like I said, to create your SQL queries. But once the string is built, it's not composable. The string is the string. And even if you have a function that returns like a SQL statement, usually that type is just a string. So it's like completely opaque. You don't know what it looks like. Also, it's a bit error prone because there's nothing in your like IDE or in the type system that helps you make sure that this string is actually correct SQL. It's like stringly type in the strongest possible sense. But what if there's some kind of like a middle ground? Yeah, I don't know why I choose like a guy in a business suit with a diver's helmet, but there's some kind of like, I don't know, worlds colliding here. But anyway, the basic idea is like, okay, what if we represented a query as a data structure? Then we add like a domain-specific language that can be used to manipulate the data structure. And this should land us somewhere in between, like, well, SQL queries and ORMs. We're sort of taking apart the stateful part of the ORM and move that out to its own separate type. So yeah, anyway, here's like an overview of the basic concept. We have our query type, which represents some abstract like representation of a query, like something we want to get from the database. We move, or we can manipulate that with our DSL, and we can also iteratively refine it. Like we can take a query as an input, and we get another query as an output. Then we create SQL from that query type, which we can then pass on to the database. But anyway, we need some kind of like basis for this query, like this query type. You know, how should we represent queries? And as luck would have it, we already have relational algebra. So, okay, so what is relational algebra? So basically, it's a theoretical foundation for SQL. So it models database rows as sets of tuples, and then defines some operations that you can perform on these tuples. And it also, like any algebra, it also defines like rules. For example, whether just like you have arithmetic, you have plus, minus, like division, etc. And they also have like properties that tells you, like, okay, can I switch the order of two operands, for example, and get the same result? or like, can I switch the order in which the operations are performed and get the same result, etc. And what this is used for in databases is, this gives you a foundation for query planning. Because query planning is basically taking like a query expression and trying to rewrite it so that operations happen in the best order possible, or like the order which means the least amount of work. And this rewrite, or like this, the rules of the algebra tells us how we can rewrite these operations. We won't use that for this help, but it's a fun thing to know. So, like I said, like an algebra is, or like why relational algebra? What's the motivation? Why even bother with this? Well, first of all, like an algebra provides certain rules, and an algebra might have certain properties that we also want in our language. And if we implement the rules of the algebra, our language will also inherit those properties. And relational algebra is a proven way to model queries, because like I said, it's already used in like databases. So we know for a fact that, like, okay, this is a solid foundation to build on. Another attractive property is that it's much smaller than SQL. And I mean, this is both an advantage and a disadvantage, depending on how you see it. And I will walk through some of those trade-offs later. But anyway, our plan of attack is that our query data structure will store a relational algebra expression. And then we will compile the relational algebra expression to SQL. And just to make that point clear, like I made this chart here, you can think of it as like sets and subsets. So relational algebra is strictly smaller than what you can do in ISO SQL, which in turn is, and the ISO SQL is like the standard SQL that all database vendors implement. But then the different like dialects of SQL, like Postgres own SQL dialect, MySQL's SQL dialect, SQL servers, SQL dialect, etc. They add a bunch of stuff on top of ISO SQL. But as you can see, like the relational algebra is the smallest one, which is kind of good as well, because then it will, we know that it will should work with all database vendors. Shouldn't matter which one you use. Okay, so what kind of operations do we have in relational algebra? Well, first of all, we have something called projection. Projection basically selects element from one of those sets, and the set is equivalent to a row in SQL. And this is equivalent also, this basically does the same thing as the select clause in standard SQL. And confusingly enough, we have another operation called selection, which is equivalent to the where clause in SQL. So yes, that part is a bit confusing. But anyway, so just like the where clause in SQL, selection takes a bunch of predicates, like logical operators, and drops all the rows that don't match the predicates. And finally, relational algebra also defines a join operation, but it's very simple. Like, it only supports what you would call in SQL like a cross join. Basically, you get the Cartesian product of all the rows from the tables you join on. So it's like for every row in this table, you get all the rows in the other table. And then the idea is that you use selection to narrow it down to like the join you actually want. And this is not very efficient, but it's flexible, because you can express all inner joins in terms of this cross join. And then some things that are missing from relational algebra that we might want to add to our language later is like outer joins, for example, like a left join or a right join, which means that if a row doesn't have if you try to join a row from table A with something from table B, if the equivalent row in table B is missing, you'll still get the row from A, which is, this is quite useful. You use it all the time when you write SQL. but the functions on the columns are not defined either, like those ones you can include in your select statement. There's no aggregation and there's no recursive queries. But yeah, all of these are possible extensions that you could add. So just to sort of like make this a bit more concrete, I've made a proof of concept that implements selection, projection, and joins. And it only has 3 predicates, like equality, and greater and lesser than. And of course, if you had a real implementation, you would probably add all of those extensions that I talked about and some more predicates, etc. But yes, I thought I would show you a demo. Do we have any questions about IMDb top 250? Otherwise, I have some prepared here.
No questions
No,
so far.
no, okay, I'll make up my own.
We had
then.
a shout out in the chat. So relational algebra is the core foundation here. Partly, yes, but you extended it also with saying like you need to add these outer joins, left joins, right joins, and whatnot.
Yeah, to
you could
like,
do like sum, max, mean, etc. Yeah.
Yeah, you usually want like, I mean, if this was a real production thing, you would probably want those things, those operations as well, because they are very, very useful. But I will show you later that there's also like there's kind of like power to weight ratio trade-off here. It's sort of like speaking of the spaceships and stuff. It's like when you launch things into space, it's important that it doesn't weigh very much.
Yes.
And it's kind of the same thing with domain-specific language. Like the bigger it is, the harder it is to work with.
Yes.
But anyway, okay. So let me show you. Okay, where should I start? So, okay. So like I said, this is Python, and let's start by defining a very simple query. So I have 2 tables. One table called movies, and
I'll jump in again. We actually had one question.
Okay.
What are the most often occurring actors on the top 200 IMDb movies?
No aggregation. I'm sorry.
Well, good question.
No, but if you would have wanted, okay, let's think about that one. But like, if you would have asked, like, which movies in the top 250 are directed by Ingmar Bergman, for example?
That's a very interesting question.
Very interesting question. Let's see if we can answer that right away. So, okay, look at this fancy autocomplete.
Oh, look, you're using AI.
Oh yeah. See, so no, this not. I don't need Copilot here. It's just IPython. No. Okay, so let me just explain real quick what I did here. You can see that EQ here is a constructor for the quality operator, and then I have to specify that, okay, I want to compare the value of the column with a value. And like I said, like this is Python. There is some like OOP stuff here, like, okay, OOP haters, please calm down. This is, you can implement this just fine in like basically any programming language. There's no polymorphism, etc. necessary. But okay, let's see if we can turn this into SQL. Okay, select star from movies where director equals Ingmar Bergman. That sounds reasonable. So I just happen to have a, let's see, SQLite database. Oh, and this SQLite class is just a very thin adapter that I've written around SQLite. Basically just passes a query to it. So I can take this query, the query object, I called that Q, and pass that to the run method. And boom, there we have it. Okay. All of the movies in the top 250 directed by Ingmar Bergman.
Yes.
Okay, so we can let's try to iterate a bit on this. Like, A lot of people say that this like they enjoy 60s Bergman more. So we can check. Okay, let's get all his movies that were made after 1960. And you can see here, I'm just stacking where. So I have one where clause, and then I have another after each other. And this is the nice thing about the relational algebra. It's like the selection operator is commutative, so you can actually switch the order of it. So, and it's also associative. So I haven't included an AND operator, but I don't really need to, because it would be equivalent to filtering or to selecting twice. And this is what I'm talking about when I'm saying that, like, it's nice to have an algebra to like start with. And I mean, Haskell kind of works the same way. You have like this very strong theoretical foundation that you can then use to inform optimizations, etc. Because you know that, oh, these two expressions are the same. So I don't need to actually implement like machine code or whatever for both of them. I can just rewrite one to the other. But let's see if this worked. Okay, and years should be greater than 1960. And then I'll try to run the query again. And yeah, that worked as well. Let's do a final one, just for fun. Let's do the test the join. So I have another, I can show you the table first. I have another table called genres, which is basically like a foreign key to a movie and a genre name, because like a single movie can have multiple genres. So let's see, let's try a join. So we joined the movie table with the genre table. And if we look at the sequel now, we can see that this is just a cross join. So this will probably not do what you want, because this means for every movie, you will get a complete list of every genre in the database. So you need to add something like this. I'll just autocomplete this. I'm a bit lazy. So now we're joining on the movie, like we're joining we're filtering, so we only get rows where the foreign key actually matches the primary key of the movies table. And as you can see, like, okay, this looks all right. And let's run it again. And then we get like, as you can see, since we don't have aggregation, we get one result for the, like, we're still getting the cross product. If we had some kind of array aggregation function, we could collapse this. So it's like, would be one set of genres per movie. But you can see now, since Persona is both a thriller and a drama, it appears twice here in the list. Yeah, that's basically the first demo. But yes, also, do we have any questions?
Yeah, we have one question. Is aggregation part of the relational algebra?
No,
No?
it's not. But it does define there are some common extensions. So aggregation is one common extension. And aggregation and joins. And also, there is one part that is a bit tricky, and that is like the recursive queries is something that you usually do in databases.
Yes.
But I am whether you want to put that in your DSL, that's a very good question. I think you should have a good use
Also,
case.
this is not a question, but I'll shoot it and you can answer it. I wonder how many ORMs, query builders, that implement relational algebra organically. That is, they haven't been designed to use relational algebra, but is grown out of the needs of ORMs.
Yes.
And I can start. I built one I think it was like 20 years ago, and then the language was C++. Exactly same need. We needed some kind of query builder and started to building something along these lines. Not as thought through as this, but yeah.
Yeah.
Maybe you have more examples.
No, I think that's a very good observation, and it's something that I thought about when I was writing the presentation for this as well, because it was like should I really, like, how revolutionary is this really? Because most ORMs actually do work like this. You sort of aggregate a query, like, you know, you sort of collect, like you build up the query iteratively, and then you translate it to SQL, like when you want to execute it. But I would say most of the time this is just like the person who asked the question said, it's something that happens organically. You sort of realize, oh wait, I can do it like this.
Yes.
But if you, like, for other problem domains, it might not be as obvious. So like if you have some like if you start to learn about category theory, for example, that can inform different things you can do with functional programming. But some of those things are not, I mean, I tried learning some category theory. It was less obvious. I can say that. But yes, that's exactly right. And like I said before, like turning this into a document, I'm sure there is a closure library that does this. I mean, I would be very surprised if it wasn't.
Yes. Please continue the demo.
Yes. So, like, oh yeah. So now we saw, like, okay, we can do this thing where we translate it to SQL and run our queries. I don't know. I know how blown away people are, like on a scale from 1 to 10. I mean, like, this might seem pretty obvious, and I would agree. Still, though, it feels like most people don't do it like this for some reason. But there's more things we can do with this. For example, since the relational algebra, it doesn't really need to define SQL. Like, we could compile it to MongoDB query language instead. Or we could execute the query directly in an in-memory database instead. So, for example, let's say you want to, I don't know, write some unit tests. Then you actually wouldn't need like a test database. You could actually take this query and execute it in memory. Or like you could even do something like where a client, for example, could send like a safe subset of this relational algebra to the server to be executed on the server. Because since it's not like translated to any concrete query language, it's just an abstract representation of, basically it's a program. And with the program, you can either compile it like to a query language, or you can interpret it. So that's what I'm going to show you in a few slides. I just want to show an example of, like, I didn't bother to implement this, but here's like how it could look like if you like decided, no, I want to compile this to Mongo query language instead. So basically, like the relational algebra language is less expressive than the Mongo query language, so it should be perfectly fine to translate it to MongoDB queries as well. And this is what I'm talking about when I said that there's a trade-off between like power and weight, because the more stuff you add to your language, the harder it's going to be to translate it to different kinds of representations. And definitely, like at some point, if you make it big enough, like an in-memory interpreter would essentially be like a relational database. So you have to find some kind of like sweet spot. But yeah, I'm just gonna show you real quick the in-memory version. So I made another uh, import it first. Basically, this is an in-memory database. Let's see. Can just show you, see if I can. There we go. So you can see here that this is just Python dictionaries. But anyway, let's try with one of the queries we ran before, like one of the simpler ones maybe. Let's take this one. So this was the SQL. And then, just to show you that I'm not cheating, this is the in-memory database. And let's say we run the query, and we get the same result. So as you can see, like you can use this to like interpret the query in different ways. So you don't need a in-memory database, like because you already have one.
Cool.
But yeah, anyway, so like in conclusion, like this approach allows you to still use a familiar interface to write queries, as you would with an ORM. Like you don't need to do it exactly as I did to have like explicit constructors for equality, etc. You could build a nicer DSL on top of that that looks more like a traditional ORM, if you would want to. But the nice thing about this is that it's also composable. Like you saw, I could stack multiple where queries, or where selections on top of each other without problem. So you could have one part of the program that returns a query type and another one that refines it a little bit more. And when compared to an ORM, this has much lower coupling because it's basically just a document or a data structure that describes what the data looks that you want to fetch. So it's very, very low coupled. It's not even coupled to a specific SQL dialect or even to SQL. It's basically just an abstract description of what data you want to fetch. Or another interpretation is that it's a relational algebra program, actually. I mean, the big limitation and the big con, of course, is that it doesn't expose all of SQL, just like the ORM. And like I said, this is a matter of this is a balancing act. Like the more powerful you make it, the harder it's going to be the less flexible it's going to be. At some point, you will run into difficulty when you try to make it super, super powerful.
I'll jump in with a question.
Yes.
What's the USP of writing this yourself? Someone mentioned SQL alchemy.
Oh yeah,
does this already? What is it like the lightness? Is it like you do it yourself?
Yeah, SQL Alchemy is a really good library to compare it to because SQL Alchemy basically works like this. But SQL Alchemy's approach is a bit different. Like SQL Alchemy, as the name suggests, is sort of it lets you build a SQL program, basically, with an object-oriented interface. So SQL Alchemy is somewhere in between an ORM and this. It's much more flexible and powerful compared to ORMs, but it is how can I describe it? I mean, it is focused on SQL, and it has a lot of features. I think it has pretty much feature parity with at least IsoSQL, and probably a lot of popular vendor extensions as well.
Cool.
But yeah, it's a good question, and SQL Alchemy is a very it is very similar to this idea, except that SQL Alchemy is more powerful. I think and Now it's prediction time. I think we're going to see like a proliferation of languages that are much, much less powerful, but more focused.
Mm.
And this is not only DSLs, and we're kind of seeing this already. The now garbage collection is becoming more common, like manual memory management, much less so, etc. So I think that the abstraction barrier is just going to keep moving, and we'll see like smaller, like more focused languages in the future instead of like this like general purpose.
Yeah.
Mm?
Thank you. Also, people are mentioning in the chat like Project M36. So if you're interested, check that out. Yeah.
That one I haven't heard about.
No.
Project M36.
Yeah. Please continue, Christoffer.
Yeah, I don't know. That's I think that's all I have for today. But I'm in the Func Prog Discord if people want to get a hold of me.
Yes.
I'm also on Blue Sky. I'm also quite active on LinkedIn, unfortunately.
Yes. Yes, unfortunately.
You gotta play the game, Magnus.
Yes, you have
gotta play the game.
Yes, more people are like discussing in the chat. Really interesting. As I mentioned halfway through this presentation, I were active in a project where we kind of ran into this issue, the same thing. We were working with C++ and had some kind of ORM stuff. Then we needed to fetch a lot of data in one fetch. Then it was down to like raw SQL. And of course, things started to crash, etc. So people started to build this DSL instead. Surprise, surprise. Also, as you mentioned, I think a lot of people out there, especially developers, as Christoffer mentioned, this is your time. If you want to create your own language, it's always fun. It's like the first thing I wanted to do when I came out of university was like to create my own language for some reason. And everyone I met like, let's build this DSL, let's do this fun. Finally, we can do this fun stuff. Maybe you've seen the same, Christoffer.
No, it's really fun. I would really like to do that someday. I think Simon Peyton-Jones said something like you have the two kind of languages basically. Like you have those like languages created by one person, which usually has one user, and then you have those big serious languages created by like a committee of people, and they usually have 0 users. So
0. Okay. Okay. Yeah. Interesting. Yeah.
Yeah. At least if you make something, you can make it for yourself.
True. At least. Maybe you can convince or force someone else to use it also. Like this is the language we use for this specific problem in this company. Yeah. So then maybe you can get up to two developers, 3 developers, 4 developers. Yeah. Yes. Thank you very much, Christoffer, and people are thanking also in the chat. Thank you very much for your presentation.
Yes, thank you to everyone who managed to tune in tonight. I hope you enjoyed the presentation and that it gave you some food for thought.
Yeah.
And yeah, I'll see them around, I think. Hopefully we'll get some at the next like in person.
Yes.
Func Prog MeetUp.
Exactly. And thanks to everyone that follow us, and thanks to everyone that was very active in the chat asking questions. It's always interesting. It's especially for both of the presenters to get a lot of questions and thoughts, and it really kind of deepens and makes the presentations even better. So thank you very much. And that's it for tonight. Again, see you either in Kibra in person or see you on YouTube. Until then, have a nice and pleasant time. Cheers and bye.